Hi students, today's session 3 we are going to see the standard types of partial differential equation. So under the standard types we have 6 types is having. Now we are going to see the type 1. Equation of the form f of p comma q is equal to 0. In this type the equation contains only p and q. Other than the p and q no other term is there. Equation contains p and q only. To solve this type of equation assume that the solution to be z is equal to ax plus by plus c. Consider this given equation as 1, then assume the equation as take it as 2. Differentiate this equation to partially with respect to x. So we get dou z by dou x is equal to a. Similarly, we can write p is equal to a. Then differentiate to partially with respect to y. So we can write dou z by dou y is equal to b, which is implies q is equal to b. Substituting p and q in equation number substituting p and q in equation number 1, that is instead of p and q substitute the value a and b. So we get a relation containing a and b. We can find b in terms of a or a in terms of b. So from that equation we have only a and b. So from that we can find either the a value or either the b value. If you find the a value or b value, substitute in the uh, assumed solution, we get the complete solution. Next we go into the problem. Find the complete integral or complete solution of the partial differential equation p square plus q square minus 4pq equal to 0. See, look at this equation. This equation contains only pq, no other than this variable. So this is comes under the type 1. So for this assume z is equal to ax plus by plus c be the solution of the equation number 1. So consider this as equation number 2. So now differentiate this equation to partially with respect to x and with respect to y, we get p is equal to a and q is equal to b. So this value substitute in the given equation can be written as a square plus b square minus 4ab equal to 0. So this we consider as this is a quadratic equation in A. So we know the formula for solving the quadratic equation. A is equal to 4b plus or minus root of 16b square minus 4b square by 2. So 4b plus or minus root of 12b square by 2. 4b plus or minus take the square root for 12, we can write 2 root 3 into b. b square root is b. So now here divide through by 2 can be written as 2b plus or minus b root 3. So we got the a value. So substitute this a value in the solution. We get z is equal to 2b plus or minus b root 3 into x plus by plus c is the complete integral of the given partial differential equation. Next we go to the problem. Say problem 2. Solve the PDE PQ is equal to 2. Solution. So take this given equation as equation number 1. So here in this equation also we have only P and Q. So therefore it comes under the type 1. Let us assume the solution z is equal to ax plus by plus c. Now differentiate this equation to partially with respect to x and with respect to y. We get p is equal to a and q is equal to b. So this substitute this p and q value in equation number 1. We get ab is equal to 2. So from this you can find either the a value or b value. So here I find the value b. b is equal to 2 by a. So substitute this b value in the equation number 2. We get z is equal to ax plus 2 by a into y plus c, which is the complete integral. Next we go to the type 2. Have you understand the type 1? So now we go to the type 2. So equation of the form z is equal to px plus qy plus f of p comma q. This form is also called as Clairaut's form. So in this type we have p, x, q, y, then function of p comma q is also having, including p, q, x, z. So also include means this is a comes under the type 2. Here also let us assume z is equal to ax plus by plus c be the solution. Differentiating 2 with respect to x and y, we get p is equal to a and q is equal to b. So substitute this p and q value in the given equation, we get the complete solution. So from this complete solution, we have to differentiate that equation with respect to a with respect to b. So we get the value for that a and b. Then substitute that a and b value in the given equation in the given this solution. That is only our singular integral for the given partial differential equation. Now we go into the problem. Solve z is equal to px plus qy plus p square into q square. In an exam point of view, they won't mention it is comes under the type 1, type 2, type 3 or etc. So here we only have to identify it belongs to which type. So this is only we have a px, qy, p square, q square having. So therefore it is comes under the type 2. Consider this given equation as equation number 1. Let us assume the solution z is equal to ax plus by plus c. Differentiate equation 2 partially with respect to x and y. We get p is equal to a and q is equal to b. Substitute this p and q value in the given equation number 2. In a given equation number 1. So can be written as z is equal to ax plus by plus a square b square. So now we have to differentiate this equation 3 with respect to a, partially with respect to a. So left side we can write dou z by dou a equal to, here the differentiation of a is x plus here no a term is having, therefore second term is 0. Then the last term we have a square is having. Differentiation of a square is 2a into b square as it is. We know that differentiation with the constant is equal to 0. Therefore dou z by dou a is equal to 0, which is equal to x plus 2a b square. So from this we get the value a is equal to minus x by 2b square. Next to differentiate 3 partially with respect to b, dou z by dou b is equal to y plus 2a square b. So here we know that dou z by dou b equal to 0. So from this we can calculate the b is equal to minus y by 2a square. Next, substitute the a value in equation number 5. What is the a value? Minus x by 2b square. So substitute here. So we get the b is equal to minus x square by 2y the whole power 1 by 3. Similarly, we get the a is equal to minus y square by 2x whole power 1 by 3. Therefore, the singular solution is substitute this a and b value in the equation number 2. So we get the singular solution. Next, we go to the second problem. Using Clairaut's form, find the solution of z is equal to px plus qy plus root of 1 plus p square plus q square. So here let us assume the z is equal to ax plus by plus c be the solution. So differentiating this equation 2 partially with respect to x and y, we get p is equal to a and q is equal to b. Substitute this value in equation number 1 can be written as z is equal to ax plus by plus square root of 1 plus a square plus b square. So take this as equation number 3. So now differentiate this equation 3 partially with respect to a. We get dou z by dou a is equal to. So here differentiation of a is 1. So ax plus here the no a term having second term 0 plus here you have to first differentiate the square root. So 1 by 2 into 1 by square root of 1 plus a square plus b square into differentiation with respect to a 2a. So here we can cancel this 2. We get 0 is equal to x plus a by root of 1 plus a square plus b square. So from this we can calculate the x is equal to minus a by root of 1 plus a square plus b square. Next again differentiate 3 partially with respect to b. So we get the values equal to y is equal to minus b by root of 1 plus a square plus b square. So take this as equation number 5. So now squaring and adding the equation number 4 and 5, we get the left hand side become x square plus y square. Then the right hand side a square by here the square root will cancel. Then plus b square by here also square root will cancel. So both the denominators are same. We can add the numerators. A square plus b square by 1 plus a square plus b square. So now subtract both the sides by 1. We get 1 minus of x square plus y square equal to 1 minus a square plus b square by 1 plus a square plus b square. So now take the LCM as 1 plus a square plus b square. So can be written as 1 plus a square plus b square. Multiply this minus inside, minus a square minus b square. So now cancel the a square, then b square. So remaining we get 1 by 1 plus a square plus b square. So now interchange these two terms can be written as 1 plus a square plus b square equal to 1 by 1 minus x square minus y square. So now take the square root on both the sides. So square root of 1 plus a square plus b square equal to 1 by square root of 1 minus x square minus y square. So substitute this equation 6 and 6 in equation 4 and 5. That is, instead of root of 1 plus a square plus b square, we can substitute the value 1 minus x square minus y square. So we got the a and b value. So substitute this a and b value in equation number 3. So we get the solution x square plus y square plus z square equal to 1. This is a singular integral. So that's all. Next class we will see the type 3.